Hello student, we already learned in last video the potential energy of a system of 2-point charges, and we get here formula U is equal to Q1 Q2 upon 4 pi epsilon naught R12. Okay, this is the for 2-point charges. Now next article is we find out the expression for potential energy for a system of n point charges. Last year Q1 and Q2 two charges. Now here Q1, Q2, Q3 up to Qn number of charges. Okay, so we will find out U for all these n charges. So we already find out in last article the potential energy for 2 points. Then using this equation we integrate, means we summation of all these n particles, then we get potential energy for n point charges, because we already find out the system of 2 point charges. Okay, so equation gives an expression for potential energy for a system of 2 charges. So U is equal to, using this formula, 1 upon 4 pi epsilon naught Q1 Q2 upon R12. Now we now analyze the situation for a system of n point charges in bringing a charge Q3 from infinity to C, means R3 work done has to be done against electrostatic force of both Q1 and Q2. So now here considering Q1 point at position A, Q2 point at position B and Q3 point at position C, up to Qn number of charges are situated. So here Q1 charge exerted force on Q2 charge, and Q2 charge exerted force on Q3 charge, and also Q1 force exerted force on Q3 charge. So here work done is done against the Q1 Q2 charge to Q3 charge and Q3 charge to Q2 and Q1 charge. So formula for that, work done W3 is equal to, now find out at C point. So work 3 is equal, because we already find out Q1 Q2 in 2 point charges, we get here this potential energy. So now find out this for Q3 point. So potential at C due to Q1 and Q2 multiply by Q3. So put up the value for Q1 Q2. So potential energy for Q1 Q2 is 1 upon 4 pi epsilon naught Q1 R12 plus Q2 R23 into Q3. Okay, this point for Q3, because Q1 from R1 to 3 is the R13 is the position vector from displacement from 1 point to 3 point. This is also displacement from 2 point to 3 point. It's called a position vector. Okay, so similarly when we bring Q4 charges, we get W4 is equal to 1 upon 4 pi epsilon naught Q1 R14 plus Q2 R24 plus Q3 R34. Okay, into Q4. So the electrostatic potential energy of a system of point charges at R1 infinity and R1 and R2 up to Rn as U is equal to 1 upon 4 pi epsilon naught summation of Qi Qk upon Rik. So here distance from Q1 to Q3 charges, distance from Q2 to Q3 charges. Similarly for Q1 to Q4 charges, distance from Q2 to Q4 charges. So here we adding all these charges, we get summation. So adding R1, R2, Rn up to Rn number adds. So we get here potential energy is equal to 1 upon 4 pi epsilon naught summation of all pairs, means all these pairs from Q1 to Q3, Q1 to 3, Q2 3 and up to Qn charges. So here summation, here I represented for first charges and K represented for corresponding charges. So here Qi Qk upon Rik. This is the expression for potential energy of a system of n point charges. Okay. Now our next expression for potential energy of a single charge in an external field. Now we find out first 2-point charges, potential energy for system of 2-point charges, then n point of charges. Now a single charge, means a single charge placed in external field. Okay. So here represent a single charge Q1, means here consider a positive charge, then its surrounding produces a positive electric field, means here electric potential V, we know that. So this single charge work done against this external field. Okay, so we find out potential energy, means work done against this external field. Okay, so consider U means the potential of point charge, when the potential R vector is the position vector when we bring it from infinity to a point P. So now this point charge placed in external field, then this position of this at P point. Okay, so this charge bringing to this P point, we get here R vector, means here position of vector. So this point charge move to at P point from infinity distance. Okay, it's the infinite distance. So work done in bringing a charge Q1 from given point in external field. So work done is equal to Q into V into R vector. So now here Q is the charge, V is the potential, R is the position vector. So we find out work done. So then work done is nothing but a potential energy. So potential energy stores as the work is stored in the form of potential energy. So we get potential energy is equal to work done. So therefore potential energy is equal to QV R vector. This is the expression for potential energy of a single charge in an external field for this single charge. Now find out again next article. So this is the expression for potential energy of a system of two charges in an external field. Last article we seen for a single charge placed in external field. Now similarly for two charges. Now we have two charges. So consider charge Q1 and Q2 are located in a point in external field at distance R1 and R2. So work done when we bring charge Q1 from infinity to R1. Now work done for Q1 charge. So last point we see single point charge is Q1 up to P point. Now here Q1 and Q2 charges. Here two charges bringing toward the P points. So we find out work done first for Q1 charge and second for Q2 charge, then addition of Q1 Q2 charges, work done of charges, then we get a potential energy of system of 2-point charges. So already we find out the work is equal to QVR position vector for the single point charge. So now similarly formula for Q1 charge. So work done W1 is equal to Q1 V R1 position. So now find out similarly for Q2 charge. So work done when we bring charge Q1 from infinity to R2 now. So W2 is equal to Q2 V R2. So work done of Q2 against Q1 is given by, now against Q1, means two charges Q1 and Q2 move against to each other. Here against, so we find out this expression. So we get here 1 upon 4 pi epsilon naught Q1 Q2 upon R12. Now work done in bringing Q2 to R2. So Q2 VR2, this is Q2 VR2 vector plus Q1 Q2 upon 4 pi epsilon naught R12. Okay, so this expression come from, this is the expression for this Q2 charge, and then now this is the expression for Q1 and Q2 charge. Okay, now again let find out this situation. So Q1 work done, we find out a QV